This tutorial is our introduction to the imaging gauge system. In it, I'll cover the imaging gauge system, camera characterization, our target design, the imaging gauge software, the use of test specification profiles, activation keys, the different software editions that we offer imaging gauge in, and mounting accessories. We see three main segments of the imaging industry. The first is imaging components, where cameras, optics, lighting, software, products are being developed and produced. Imaging systems, which are companies that put together, that integrate these systems, integrate the components into systems, surveillance systems, ID system integrators, archiving bureaus, machine vision systems, and then the frontline operations, the field operations, where people are actually using those systems in order to process people or to do surveillance or archiving. We've developed imaging gauge to work in all three of those industry segments, and we've developed a way using test specification profiles to communicate between those segments. The system features of imaging gauge start with the targets, which are high quality, portable, and rugged. The software we've developed to use with those targets is powerful and accessible, easy to use, and uses standard methods and practices such as the ISO 12233 resolution measurement and methods developed at the International Color Consortium, and we use CIE color space. All of our targets use Munsell color patches. And we offer mounting solutions so that you can get the targets where they need to be and make repeatable measurements. Basically what we're doing is characterizing the system by giving it a known input and measuring the output to characterize what the system did to the input. For camera systems, the input is a slanted edge in order to determine the resolution, and the color patches are based on the Munsell color checker. We use, as I mentioned before, ISO standard for assessing resolution, and we employ a delta E measurement for color accuracy. Captured images can be displayed, reprinted, or used to do facial pattern recognition, among other things. It's important to characterize the camera at the beginning of each of these processes. Without proper equipment calibration, the images displayed may not look the same as the captured image. The same is true with hard copy. And in the case of pattern recognition, the software may have a difficult time performing if the images that were collected in a database are not properly matched to the originals. By employing imaging gauge to characterize the camera, specifications can be put in place to ensure the image quality for the downstream applications. By communicating specifications and calibrating the cameras, you'll ensure that your software and hard copy outputs more closely resemble the original, and you'll be able to optimize facial pattern recognition software. Target design and its construction starts with a lightweight 6mm PVC backer board. Onto that we adhere a high-res silver halide target for our resolution features. And we use color patches that are made from pigment-based Munsell color patches that we purchase from X-Rite. These are used in the corners for uniformity, for tone scale along the bottom, and for color accuracy patches. We provide the imaging gauge targets in 3 sizes: a 1 foot by 1 foot, 2 foot by 2 foot, and a 4 foot by 4 foot target. We do that in order to maximize the size of the target inside the field of view of the camera. The larger targets enable low resolution applications and to improve the signal to noise ratio for color. Imaging gauge system operation starts with the imaging gauge target. The camera captures the test target and feeds it to imaging gauge software, which does image analysis, compares the images to specification, and displays and saves the test results. The software user interface is designed for ease of use and easy accessibility to all the data. I'm showing the Enterprise Edition here. Along the top are navigation tabs. Instructions walk the operator through the different steps of analyzing an image. 3-step controls are used to analyze the image. Profile information tells the operator that they're using the correct profile. And different options are available at the bottom of the user interface. When Imaging Gauge analyzes an image, it extracts data from the regions of interest that are placed on the target. Uniformity measurements are made in the 4 corners of the image. Along the bottom, the grayscale patches are used to analyze tone scale, neutral balance, and noise. The remaining color patches are used to assess color accuracy. And the slanted edge feature is used to calculate resolution and registration. After an image has been analyzed, the results are displayed on the front panel, clearly stating whether the image passed or failed. In this case, it shows a failed image. The next tab shows a summary of all the image metrics that were measured. In this case, the failed portion is the sensor resolution and color accuracy. To get more details on the resolution, you can click the Resolution Details tab, and this tells you sensor resolution, optical efficiency, and the functional resolution measurements. You can see that the sensor resolution measurement of 50 is lower than the spec of 80, which is why it failed. For more information on resolution, you can click the Horizontal SFR Curves tab to see the actual SFR curves for that image. After the image is analyzed, you can save the data, which appends the data from that image to a summary file. That allows you to do QC testing over time for all the images that have been run and saved. It also saves data to an individual file. This individual file includes additional data, such as the SFR curves and the CLAB values. That can be exported to a template that displays the information in Excel in a way that's much easier to read than the text file. Saving the individual files is available for the Enterprise and Engineering versions, but is not included with the Deployment Edition. Software profiles allow you to easily switch between different camera setup configurations. They simplify instructions to operators in a production environment, and they allow you to exchange the profiles within an organization to ensure consistent testing. ImageEngage requires that the software be activated for one workstation and that image actuations be added in order to continue running the software. The software includes an account management interface to allow easy access to your account, which shows the current number of images and the software license status. ImageEngage is offered in 3 editions: Engineering, Enterprise, and Deployment. All 3 editions perform the full suite of image quality metrics. They can use multiple profiles, and they display and save summary results. However, only the Engineering and Enterprise versions display and save detailed results. They also include the resolution specification wizard and the color accuracy specification wizard. Both Engineering and Enterprise can also read and edit text profiles, but only the Enterprise version can read encrypted and edit encrypted profiles. The Deployment version reads encrypted test profiles, and the Enterprise version creates technical contact information that's used with the Deployment version. Mounting accessories are available to allow easy, repeatable deployment to the field. Mounting starts with the heavy-duty tripod. There's an aluminum target arm with a foam grip handle that's connected through a grip head to a target mount adapter, and finally to brackets that adhere to the targets with industrial Velcro. The following demo will show some of the main features of ImageEngage. So this will be a quick demo to show as an intro to ImageEngage. The other tutorials will get into more depth. From the front panel, you select Open, navigate to an image, draw a square around the target, click Draw, and automatically these regions are placed on top of the target. Inspect the regions and select Run. And you'll get feedback whether the target passed or failed specifications. Summary gives you detail for each of the metrics, and then resolution details, color details give more information about each of the measurements. That ends this tutorial. Thank you for your attention, and please contact